My name is Swaib Semiyaga, a PhD student working on decentralized management of faecal sludge in urban slum areas. I'm using Kampala in Uganda as my case study. My research is focused on faecal sludge management technologies in urban slum areas with limited space and access to mechanized emptying. In such slum settings of Kampala, over 95% of sanitation facilities in use are pit latrines, which are occasionally lined in places of high water table. One of the objectives of my PhD work is to come up with mechanisms for dewatering faecal sludge from pit latrines in such settings. There was a need to understand the characteristics of faecal sludge generated in such slum settings and determine how these influence faecal sludge dewatability. The major dewatability characteristics considered in this study were particle size distribution, sand content, and viscosity of faecal sludge. A comparative assessment of the dewatability characteristics in lined and unlined pit latrine sludge was carried out. This was done by selecting 4 slum areas which had both low and high water table. From each slum area, 8 lined pit latrines and 8 unlined pit latrines were used in the study. From each of the pit latrines, 4 grab samples were obtained at different depths. These were mixed together and 1 composite sample was obtained. This was transported to the laboratory for analysis. When samples arrive in the lab, we do initial preparation by passing them through 5mm sieve. The initial parameters of temperature, pH, and electroconductivity are then measured using a meter. Other characterization parameters of COD, total solids, total volatile solids, and free water are determined using homogenized sample. We homogenize the sample by use of a blender. COD is determined using vials, and values are read from the spectrophotometer. Total solids is determined gravimetrically by use of oven set at 105 degrees Celsius. Total volatile solids is gravimetrically determined by use of a MAFO furnace set at 550 degrees Celsius. The parameters which affect dewatability determined are sand content, viscosity, and particle size distribution. Viscosity is determined using a viscometer. For sand content, we use the acid method. The particle size distribution, this is obtained by sieving through a series of sieves under a water jet. The sieves used are 1mm, 75 micrometer, and 32 micrometer. The dewatability indicated by capillary suction time is determined using a capillary suction timer. From these results, we shall be able to determine the variation in particle size distribution, sand content, viscosity, and dewatability of faecal sludge between lined and unlined pit latrines in such slum settings. Furthermore, we shall tell the variations within lined or unlined pit latrines in a particular slum and between slums. The influence of these factors to fecal sludge dewatability will be determined, and the most sensitive parameters identified. It will be upon the basis of these most sensitive parameters that a synthetically made fecal sludge simulant will be made to further explain the obtained findings. These will form a basis of the design of the appropriate fecal sludge dewatering technologies.